Now we'll see more details of doing the IO using interrupts. That concept is also known as interrupt driven IO. In interrupt driven IO, what are we going to do is we are going to take the help of interrupts. Forget about the remaining code, like how you write it's up to you. But we will see first what interrupt is going to give us. Okay, so we will see that. So from now onwards, every device is going to have a capacity of generating the interrupt. Example, keyboard can generate an interrupt. So this is keyboard register as usual. Whenever data is available, so keyboard is also going to have a small processor or circuit, already I told you, right? So that circuit is going to generate a interrupt whenever data is available. Such a way that keyboard will be designed. Now when user hits keyboard, then data will be slowly transferred here. Once it is done, then we are going to get interrupt. Now, what this interrupt is going to provide as I will tell you. So whenever interrupt comes, then there will be an interrupt controller. So there will be a circuit. So that circuit is going to do some fixed, otherwise some specified task. What the task is? So that interrupt is going to disturb your program, because at this moment I am assuming that because you are using interrupts means then you will be maybe busy doing some other logic or other program, correct? So it's like this currently. So program counter is showing 500. That means you are doing some work, whatever. I don't want to discuss that. But currently your processor is executing an instruction at 500. Okay. So let me assume that this is memory location 500. Okay. For time being. That's why now currently we are executing instructions here. Right. Now at that time, let's say interrupt comes. What does it mean? Why interrupt came? Because you were waiting, already you were waiting, or your program, maybe this program or some another program, some program was waiting for this data. Now the data is ready. Now you have to take the data, right? So immediately what happens, your circuit, this interrupt controller is designed such a way that automatically some works, some tasks will be done. What is one of the important task is your program counter will be updated with new address. What is that? That is not a normal address now. So that will be starting address of this interrupt service routine. Sir, what is interrupt service routine? Interrupt service routine is very easy to understand. So first of all, ask yourself, what is the work you want to do here? Actually, what's the work here? Did you remember in polling, otherwise in interrupt driven IO, finally we have to take the data from keyboard register, right? That is the story. So to take the data was not available, now it is available, you take it, correct? Then to take the data, we need some set of instructions, correct? So that is called interrupt service routine. So interrupt service routine contains instructions such a way that data will be, otherwise desired task, whatever the task you are going to do, otherwise you are expecting, that will be done. So who will write this interrupt service routine? You have to write if you want to access the data from the keyboard. Okay, already we have seen how to write a code such a way that we can access the data from the keyboard. Only polling part we should not do, but remaining logic we have to do. That means we have to assume that whenever interrupt comes, then data is available, then this interrupt service routine is going to have some instructions such a way that data will be transferred from this keyboard register to main memory. Okay, such a way we are planning. Otherwise it depends on the requirement. Actually, what exactly you want to do, what exactly you want to do with this data, that is nothing but interrupt service routine code. Okay, assume that we have a write code, then it is, let's say, initially located here. One interesting question here, sir, you are writing interrupt service routine at memory address 100, right? But how processor knows it, correct? That's one interesting question. How this interrupt creator is knowing it? No, interrupt creator won't know. Interrupt, this keyboard is simply generating interrupt. Then how this interrupt controller will know it, sir? Like, so how suddenly your execution started here? That's fine. So what is going to happen, I will tell you now. There are a lot of questions we have to answer. One is, whenever interrupt is generated, there will be some circuit. Assume at this moment that there is a circuit. We are not discussing how to design that circuit, that will be later. But here we are assuming, understanding that, let's say there is a circuit that is going to generate, that is going to do some work. What is that work is? First important work, the starting address of interrupt service routine will be loaded. That is one very important step. Okay, so that what happens really, that is done. Now your processor is just blind, he doesn't know anything. Your processor executes the instructions which are pointed by program counter. You remember one thing, processor is not intelligent. Processor is a mechanical device or electronic device. Your processor blindly, it is in a cycle or infinite loop, I can say. It is periodically fetching the instructions from the memory and it is executing. But sir, how does it know that there is some instruction at somewhere? That's why program counter helps it. So in the early morning when your processor wakes up, it will take the data from program counter, like it will see the address, it's go there and it will fetch the instructions and it executes. Then again program counter automatically will be incremented. You know that story again, right? So that's why now at this moment, whenever interrupt signal is generated, so because of this circuitry, automatically this program counter will be loaded with 100. Now, sir, because your interrupt service routine is at 100, you know and I know, but how that circuit knows, like, is it fixed thing? Yes, one of the easy implementation I am telling, one easy implementation what we can do is here, one more thing. These are all ideas, right? And we are just learning basics, but real machines, can have sophisticated interrupt service logics. Okay, now what I am assuming is one idea I am telling. Generally, if there is only one device, just for simplicity, there is only one device, it is creating the interrupt, then what can we do is always we can store interrupt service routine in a fixed memory locations like this 100, 104, 108. Okay, now we can have one separate register like this. So this is interrupt register, let's say. Okay, so whenever there is an interrupt, we have to look here, interrupt register, where we write interrupt service address 100. So that what happens, now we can design like this. So whenever keyboard generates a signal, then interrupts controller will start working. We have to design such a way that the circuit should come here. I mean, because of that circuitry, this data should be transferred here. Such a way if you plan, that's it. Now, sir, tomorrow if I want to change my interrupt service routines address, I want to keep somewhere. Where you want to keep? Sir, I want to keep at 200 to 202, sir. If you want to keep at 200, 200, 202, what you do is, in this register, you write 200. Now, story is same again. Whenever keyboard, generates interrupt, then automatically the circuit will work and it will blindly transfer this data from here to here. So, because that interrupt register, which we are assuming that we have. So, and one more thing, your real machines might not follow the same technique. They can have different techniques, but this is a simple idea. So automatically this data will be transferred to program counter, right? If once it is done, then now program comes to normal thing. That means now your CPU starts executing remaining instructions. Remaining means whatever is shown in the program counter. Since program counter currently is showing 200, then it will go here and it will execute instruction at 200. Then 201, 202. Really it happens, what is going to happen? Definitely, then interrupt service routine is going to be executed, then keyboard will be served, correct? Sir, I have a doubt, but I was happily executing some instructions at 500, right, before interrupt. But once interrupt this service is done, whenever I take the data, then work is done, but I should go to my own program, right? Correct? That means I have to continue from next address. Since program counter is showing 500, when interrupt comes, then once interrupt is done, again program counter should show 500. But who will do that? Again this circuit will do? No. This circuit is simply going to transfer this interrupt registers data here to program counter. Because of that, what is going to happen? Your program's control is modified so that interrupt service routine will be invoked. But in interrupt service routine, you have to write, I show here. Your interrupt service routine should be designed such a way that end of the day, that means in the interrupt service routine, whoever writes end of the day, you write like this. So return to old program counter. That means return that old program counter. Such a way we have to write. So there should be a separate instruction. Let's say that is return from interrupt. Okay. We can design. We have to design all these things in a circuit. I will tell you. So what we do is we will maintain a register. Like did you remember to implement functions? We maintained a link register, right? Here also same kind of link register kind of thing we have to maintain. In that program counter, old program counter was what? 500, right? We store here 500. Okay. Now, so now what is going to happen? Whenever instructions in interrupt service routine is executed, because of return from interrupt, whenever this line is executed by your hardware, so this should be a instruction. Because of this instruction, this link register data will be stored back to program counter. Such a way we have to have one instruction, right? So this is what called return from interrupt. Generally, lot of machines will definitely have this kind of return from interrupt instruction. Did you remember? Please recall, how did you implement functions? Exactly same way interrupts will be implemented. So when you implemented functions, we have two things. To call a function, we have a instruction. To come back, to return from the call, we had an instruction, right? Return. Did you remember? Similarly, when any machine supports interrupts, probably that machine will have one instruction, that is return from interrupt. Whenever that interrupt is that instruction is executed, like if you use it, automatically the link register data will be stored back. Really, if it happens, then what is going to happen? Happily we served the keyboard and we came back and we are continuing the job, right? Now let us summarize. So finally, what you learned here is, you have some IO device, there is a data, but initially it was not available. Then you have written specially one interrupt service routine, okay, and that interrupt service routine is located in the memory from, let's say, 1000. I'm changing the lines so that it will not be routine, right? I'm changing the addresses so that it will be interesting for you. 1000, 1001, 1002. Even now I can ask some questions, so you can answer them, right? One question I would like to ask: whenever interrupt is generated, what is going to happen? Immediately this interrupt controller will start working. This is a circuit, it's a part of your processor. So this circuit will start working, and immediately, so there will be some dedicated register. The dedicated register, let's call interrupt register, where you are storing the interrupt service routines address, okay, interrupt register. So this interrupt register contains now 1000. Now automatically, remember one thing, whenever interrupt comes, program counter, wherever it is showing currently, let's say it is working at 5000. That means you are executing the lines of some program where the address is 5000. Assume that, let's say, for time being, so this is 5000. So you are currently executing here. While executing here, interrupt came. Now what happened, sir? Sir, we have one more doubt. What is that? When I am executing a program, currently I am executing some line, whatever it is, at 5000. Then I ask one question. What were you doing at that time? You are executing one instruction, right, which is at 5000. Then what can happen is, so that interrupt can come at any time. So let's say this is a time period where your actual instruction get executed. Then the interrupt might occur here or here or here, anywhere. Now my question, what we have to do? Should you immediately respond? This interrupt controller circuit should be designed such a way that immediately we have to handle the interrupt. Otherwise, should we complete at least this instruction? So majority of the times, generally, that the circuits will be designed such a way that entire instruction will be completed. Okay, that's a good idea. We can't stop in between, but this is also a possibility, very rare case. Remember this rare case. In some rare cases, I will explain that further. In some rare cases, we have to stop immediately and we have to go to interrupt service routine. But majority of the times, or most of the times, we have to complete that instruction. Then after that, we have to go to interrupt service routine, which is located at 1000 in this example. Sir, should I write a program like that? No. This entire thing is part of the circuitry or your hardware. Okay. So your hardware will be designed. This is, let's say, that such hardware. So your hardware is designed such a way that whenever the device creates an interrupt, then that hardware should help us in doing these two things. One is, continuing our execution first of all. Okay, we should not stop our execution. We should complete our instruction. then the circuit should become active. And two things, one is this interrupt register, whatever that is showing, what is that, let's say 1000, right? That means your interrupt service routine is started at 1000. That 1000 should be transferred here, but before that, that 5000, did you remember that 5000? That's why that I can say first step. So let us do like this. So your hardware should help us such a way that the next address, that means 5000, let's say I assume that again the next memory instruction or instructions address is 5004, then that 5004 will be stored in a link register, okay, some dedicated register. Like for functions we use it, right? In the same way, this link register can be used for storing that 5004. That means once interrupt is completed, I will come here, okay. So that is going to come from generally hardware support. Second thing, the circuit should be designed such a way that this data, whatever it is, this interrupt register is there, right? That data should be transferred to your program counter. Really, if it happens, what is going to happen? That's it, these two things. Now interrupt, hardware support is done. Now blindly what your processor will do, it will blindly execute the instruction which is located at program counter. Then 1000 means this line will be executed, which is nothing but interrupt service routine. Now interrupt service routine is going to take the data from the keyboard, if it is keyboard, otherwise appropriate thing, right? Now once it is done, what should we do? Then should I, after 1002, should if I go to 1003, that will be wrong, right? Because 1002 is the end of the interrupt service routine. Once it is done, we should come back to program counter and we should execute the normal program. What were we doing? Same thing we should do. That means, so 1000 should be executed. That means that's quite common. Your processor can do it. Whenever you write, whenever program counter is 1000, the next time what happens? Program counter will be incremented appropriately. Here let me take 1004, 1008, okay, so that each instruction is taking 4 bytes of space. So 1000, automatically 1000 will become 1004, 1004 will become 1008, because it's quite common. Whenever a program is getting executed under processor is designed such a way that program counter will be incremented periodically, right? So I already discussed that thing, not a problem for us, right? Then after that 1008, when interrupt service routine is done, we should come back to that 5004. That's why in interrupt service routine, whoever is going to design interrupt service routine, that software code, whoever is going to write on that, of course that instruction set will give you one instruction called return from instruction, interrupt, return from interrupt, okay. Assume that such instruction is there, okay. So sir, is it compulsory? Most of the times it is compulsory, depends on again architectures, okay. I am assuming that one of the architecture which is supporting us through this instruction, what is that? Return from interrupt. If really this instruction is there, what it is going to do, I will tell you. So when you execute this return from interrupt, it's like returning from function. Directly it will go to link register and that data will be copied here. Such a way this instruction is designed. Such a way hardware is going to be designed. Whenever this instruction is executed, so 5004 will be moved. Now here one more question, sir. Why it happens such a way? Circuitry is designed. If you want to know that, we should understand how instruction set architecture will be designed. It's a big story, okay. So generally we will be studying that in control memory part, okay, some part of it. So now that's why at this moment as a programmer you can understand that whenever return from interrupt instruction is executed, then the already stored address is there, right? 5004, that will be copied here. Is not that sufficient for us? Yes, absolutely it is sufficient, okay. Now here, sir, this instruction should I write or someone will write? No, you should write. You means whoever wants to implement interrupt service routine for keyboard, okay. Generally whoever designs drivers, they should do this part, okay. So that is what the idea. Now there are two things, we are writing programs and you are getting hardware support. Here what is hardware support? The hardware support is through signal. First one signal comes, interrupt signal. Second, some circuit, so we have some circuit, okay, hardware. That hardware is helping us in remembering two things automatically. One is in the link register, program counter, program counter plus plus, I can say, otherwise program counter plus 1 will be stored, otherwise next address will be stored in link register. Second one, in interrupt register, the interrupt service routine will be stored, right? That two things will be done by, I can say, your hardware, right? Now here one more thing, sir, this interrupt registers data will be transferred to program counter, and in the link register the next address will be remembered. These two things will be done by hardware. Sir, as a programmer, what should I do to implement interrupt service routine? Very simple. Write a logic such a way that data can be taken from the IO device. Second thing, write return from instruction such a way that once your entire work is done, then you can come back to your normal flow, right? For that return from interrupt you have to write. Apart from that, everything is same. Okay, this is about interrupt driven IO. It's not only for keyboard, for any device we can write this kind of stuff. Okay, now some more details you should know about interrupts is one thing. Sir, you said interrupts are always, whenever interrupt comes, that instruction will be completed, right? Is it always true? It's not always true. Why? Because sometimes we have to stop that instruction immediately. Why, sir? I will tell you. So, example, let's say you have an interrupt. So, that is related to the current instruction. Example, let's say you are executing one instruction. There is a flaw in the instruction. That means, example, that instruction is something like load something R1 comma memory address M. Okay. Now the corresponding opcode for load is 0010 just for time being. So R1 is, let's say, 01. This memory address is 101. Randomly I am writing binary pattern. But the actual load's machine address is, opcode is 0010. But user wrote 0011. Okay. That means what? This is not load, and there is no opcode like 0011. Okay, I am assuming one possibility. What is it? There is no opcode like 0011, but user wrote it. Then you get an error. What is that error? Wrong instruction. When you write wrong instruction, then interrupt comes, right? So of course it is not from IO devices, from the other part of the control. Okay, so assume that, let's say, at that time also interrupt comes. Then invalid instruction interrupt, if that comes, what should we do? Should we complete it? Should we execute it? We can't, because the instruction itself is wrong. Similarly, division by 0 error. Example, your instruction is dividing a number by 0. Then what? It's a invalid instruction, correct? So that means, there is a logical error. When such kind of instructions are executed, we should not complete. We can't complete. We should immediately stop it. That's why majority of the times, these are all exceptions. If majority of the times, if instruction is good, okay, but interrupts are coming from the devices because they want service. For that, we have to stop we have to complete the instruction. Then we have to go to the interrupt service. But there are some interrupts, okay, because they will be created because of the exceptions, okay, like division by 0. Otherwise, opcode error. Otherwise, memory error. In the memory, there is a, I can say sometimes, memory register will have some errors. That means you stored 010, but what happened? There is a bit error, like, Hamming code error. Did you remember in computer networks I taught you, right? Sometimes some bits will be corrupted. What? The bits which are stored in your memory got corrupted. Then at that time, memory device will throw an error, or it creates an interrupt. Okay, that is nothing but exception. So when such kind of interrupts, whenever there is exception, still interrupt comes, then now should we complete the instruction? No, correct? So that's why when you are executing the instruction, sometimes it is not possible to execute the instruction, because like I'm talking about specially memory error. You understood the remaining parts. Example, let's say you are loading from memory, okay, into register R1. But the memory address, whatever you specified, it has some problem. You can't use it. Otherwise, the data at that memory location got bit errors. Okay, we can't take it now. Then at that time, so you can't complete this instruction. That's what I'm saying. When you cannot complete the instruction, then how can I complete and I can service the routine, right? That is not possible. That's why there are two things. One is everything is good and interrupts are coming because some already I told you, like, servicing the keyboard, such kind of stuff. Then at that time we have to complete our instructions. There are some instructions which cannot be completed when interrupt comes. Then what to do? We should stop immediately that instruction, and we have to address that interrupt. There are two things. Okay, remember it. Now we will see the remaining stuff. Finally, you realize that interrupt driven IO is better than definitely program driven IO. Correct? Now we will see the differences, like, and advantages and disadvantages. I don't see any disadvantage, advantage of program driven IO. Definitely interrupt driven IO has lot of advantages. Correct? One thing, we can save lot of CPU's time. Correct? And you can utilize CPU effectively. Right? That is about interrupt driven versus program driven. Now we'll see some more details of interrupt driven IO. So far we just assumed that we have one device. Correct? What if there are multiple devices? How they are going to take the services? We will see that.